All right, so now we're going to take a look at some equations that have the distributive property in them. So sometimes we will need to work with linear equations where we must use the distributive property before we can isolate the variable. So exercise 2, solve each of the following equations by first using the distributive property to rewrite one or both sides of the equation. Do a formal check of your work. Okay, so distributive property. The reason why I know I need to use the distributive property is because I see parentheses. If I see parentheses with stuff inside, not just one number, but multiple things, I need to do distributive property, which means I need to distribute this 2. Distribute means multiply. So remember, we make these little arrows to remind ourselves that we have to do the multiplication to both terms that are on the inside of the equation. So I'm going to rewrite this. 2x times, or 2 times x is 2x. 2 times positive 3 is a positive 6. Okay, and then on the other side of the equation, there's nothing to do, okay, yet at least, so I'm just leaving it alone. Okay, now I have simplified this by doing my distributive property, and now I have what looks like just a regular equation with variables on both sides. So the first step here would be to make sure that I get variables only on one side. Right now I have it on 2 sides, so I have to get rid of the smaller one. The smaller one in this case is just this x. Remember, that's just a 1x. So in order to get rid of that, I'm going to subtract x, and I'm going to do it to both sides. Notice how I am lining it up under my 2x because those are like terms. So the subtraction happens here. It doesn't happen over here. This 6, nothing's happening with it. I'm just dropping it down. Okay? X take away x is 0, so all I have left on this side is my 11. 2x's take away x just gives me x, which is kind of nice because, as you guys will see in a sec, this actually takes one step out of the way for us. But let's keep going on our normal 2-step equations. Make sure you have your equal sign on the line. Equal sign on the line. All right, 11 down, so that comes over here. And now I have this equation here, which says 11, or x plus 6 equals 11. Okay. So now I have a regular 2-step problem. I just got to solve it. My first step is to get rid of any addition or subtraction. So I see a plus 6. I got to do the opposite, which is take away 6. So I'm going to do that to both sides, making sure my equation stays balanced. I'm going to put my equal sign on the line. Equal sign on the line. All right. 11 take away 6 just gives me a 5 on this side. Okay, these cancel out. 6 take away 6 is 0. All I have left on this side is x. Now, some people would want to do a second step here. And the reason why is because this is a 2-step problem, or at least it looks like a 2-step problem. So once we got to the 2-step part of it, it seems like we should be doing 2 steps. But notice, I have gotten to a point where I know what x equals. The whole point in solving this equation was to isolate the variable to figure out what x is. Well, I've just found what x is. Now, technically, you could do another step here. You could do divide, and what you're dividing by is the number next to x. Remember, that's an invisible 1. But dividing by 1 doesn't change anything, right? 1 divided by 1 is still just 1, or 1x. 5 divided by 1 is still just 5. So you don't have to do this step, okay? This step is not necessary because there was a 1 in front of the x. If there's any other number in front of the x, we have to do that division, okay? But clearly, I just got back to what I had originally, x equals 5, x equals 5. So you didn't need that step, but I'm just showing you why that step doesn't need it, because we got a 1 there, right? Either way, our answer is x equals 5. So you guys are going to try one of these on your own. All right, remember to do the distributive property first. You got to get rid of all parentheses before you start any combining like terms or start any solving of a 2-step equation, okay? Good luck, and I'll see you in the next video.